Hello everyone, welcome to FioLabs. In today's session, we'll be coding for the Perceptron, which is nothing but artificial neuron. Let's start by revising the structure of the Perceptron. For that, I need to import IPython display, and so let me just run this code so that you can see the picture of the perceptron. So in today's session, we'll be using only two inputs and one bias, which is by default, and the input of the bias will always be equal to 1. And there are three weights which are randomly initialized. So these three, so all of this will be multiplied and summed up, which is the summation, and this summation is then passed on to the nonlinear activation function, which gives us the final output y hat. So let's go ahead with the coding part, and before doing that, let's just review about this mathematical formula. So W naught is nothing but the weight of the bias, and Xi Wi is nothing but the input weights and inputs, values of the inputs. So they are then fed into this nonlinear equation G, and then the final output is given as y hat. So let's start by importing NumPy, which is used for mathematical calculations. So here the weights are randomly initialized. We need only two weights, so the size is equal to 2, and we are rounding off the decimal places by 2. Now let's do the coding for the bias weight. So NumPy is imported as np, so np dot a round, and it is rounded off to 2 decimal places. But before that, we need to randomly initialize bias weight. For this, we need only one bias weight, so size is equal to only 1, and decimals is given as 2 places, so it's just 2. Let's run this code by clicking here. Yeah, so that's done. Now let's just check what are the weights which are randomly assigned, and for the bias and for the inputs as well. So the first weight is 0.14, as you can see here, and the second weight is 0.77, and the bias weight is given as 0.93. So now let's go ahead and assign values to the input 1 and to input 2. I've already assigned 0.7 value for the input 1, and now let's take maybe 0.86 for the input 2 and run the code. So x1 is 0.7 and x2 is 0.86. We don't have to assign this every time. So all we have to do is use these variables x1 and x2 for the future. Now let's calculate the linear combination of these inputs and their weights. So I have assigned z1 variable for that. So if you go back to our mathematical equation, you can see that x1 w1 plus x2 w2 plus w0. So here it's the same. So x1 into w0, which is like the first value in the array, plus x2 into w of 1, which is the second value from the array, plus bias weight. And then we run the code. We get the linear combination of inputs and their weights as 1.6902. Now, since we got the sum, this will be fed into the activation function. Here we have used sigmoid function. Let's just visualize how that sigmoid function looks like and its formula. So the formula is given as 1 by 1 plus e power minus z, and this sigmoid function ranges from 0 to 1. So whatever you have fed into this equation will be between the output will be between 0 and 1, and not more than that or less than that. So this sigmoid function will be useful when you have the when you have to output based on probability. So I have assigned a1 activation function, and I have defined the function as 1 by 1 plus np dot exponential of minus z1, which is our summation variable. So let's just run the code and see the output. So I'm printing the output here. The output of the network for x1 is equal to 0.7 and x2 is equal to 0.887 is 0.8443. So the final output for us is 0.8443. So this is how you build a basic building block of a neural network. So let's just go ahead and commit the notebook, which you can find on the top right corner. It will provide you a link to open the version, which you can see in the next tab. So here is all your code. So whenever you run this code again and again, it will produce different results here. I'll be providing the link for this notebook in the description box below. So what you can do is just when you come to this website, you can click on the copy and edit option here. It will direct you to your own notebook in the kaggle.com. So you can use that. So thank you for watching this video. I hope you enjoyed and learned about the structure of the perceptron and the internal workings of a perceptron. See you in another video. Please subscribe, like and comment. Thank you.